G'day, everybody. Thanks for joining me today. My name is Paul McCarty. I really want to thank the Project Discovery team for inviting me to speak at the Hardly Strictly Security event. I'm a huge fan of the Project Discovery open source ecosystem. I use the tools almost every day myself. I'm author of a couple of nuclei templates, including the AWS detection template. I've been working at the intersection of software development and security for a very long time. Don't let the baby face fool you. I've been in the game a long, long time. Open source has been a part of that journey for most of my career since the early 90s. I've been a consumer, a contributor, and a maintainer of open source. And this ecosystem is really, really important to me. So when this conference came along, I thought this is great. This is a great opportunity for me to, speak to my appreciation for the open source ecosystem, but also about how do we make it more secure. And that's why today I want to talk about open source software and the software supply chains that build those open source projects that we all rely on. And that's what we're talking about today. So, like all great open source stories, this one starts with a failed continuous integration pipeline. This happened about a year ago. This is a true story, by the way. This happened about a year ago for a customer when I was still at my startup, SecureStack. Now, as you can see here, that we have a failed build stage or a failed test stage and a continuous integration pipeline. The thing is, this pipeline had been running successfully for, like years. And then suddenly one day it fails at the software composition analysis step. Now, this customer asked me to take a look at it because they thought that something was wrong with the SecureStack scanner. So as I took a look at the output of the pipeline, I realized pretty quickly that the security scanning stage was actually failing because an important file was missing. Now, this build stage hadn't created a package manifest file, and you don't have to worry about exactly what a package manifest file is, but it's something that most programming languages use to identify what ingredients are in the application. And for whatever reason, it couldn't create or find its package manifest file. Now, this pipeline, like I said, had been running for years and years. Why had it suddenly stopped? This was a mystery. I thought, well, that's weird. This particular scanner, too, was smart enough to know that if it didn't see that there was a pre-existing manifest file, that it would build one automatically. But that was failing. So that was really, really unusual. We didn't see this error very often. So I put that detective hat on and I started researching in more detail. Now, I looked at the I looked at the source code for this project, this customer project, and I realized by looking at the latest set of merges that a really big change had happened in this application that day. They had actually replaced Node.js with another JavaScript runtime ecosystem, and one of the devs had done that, and that was a big deal. And the reason it was a big deal is because as I started looking at that runtime, I realized that it wasn't building, or it couldn't use the standard manifest file. In fact, it didn't create one, didn't use one, couldn't build one. And that was a problem because that broke stuff. Actually, it broke out a lot of things. First, we couldn't run our software composition analysis stage. We didn't have any visibility. Because of this, we didn't have any visibility into what was now in the application. Like, we didn't know if there were any other changes that had been introduced by that developer or any other developers during that same time period. So we didn't have that visibility. Next, because we didn't know what components were in the application, we couldn't create a software bill of materials, otherwise known as an SBOM. Now, this customer was contractually obligated to provide an SBOM to their customers. And because of the type of customer this organization was, they also had governmental requirements. And that meant that they were failing both their customer contractual obligations, but also their obligations to the government. And this was becoming a really big problem for them very quickly. Now they needed to get the application working again. So what we had to do is we had to turn off the dependency component analysis step, that SCA step. And that meant that now we were kind of breaking some of the pre-agreement, that the things we agreed on, the customer was with their customers. So they weren't doing their security scanning anymore either. So they didn't know what was in the application. They couldn't create an SBOM. They weren't doing the security scanning, all these things they had promised to their customer. And they were in the middle of a SOC 2 type 2 audit. And that meant that they actually failed their audit because they couldn't show that they had consistently followed security best practices. This made their customers upset. There obviously was a lot of turmoil, all from this one kind of change early in the software supply chain. Now, before you say, wow, that's just a compliance thing, let's imagine that wasn't the outcome. Let's imagine instead that the attackers actually had used a runtime, a 0 day in that new runtime, or some other security issue inside of that new JavaScript runtime, and suddenly they had access to this customer's applications and all the customers of that customer, right? And this is the kind of thing that we are worried about with the xz-utils software supply chain attack that we saw last weekend. So it's a little bit more than just compliance, right? Or possibly a little bit more than that. So let's talk about what is the software supply chain, and frankly, why would you care? Well, the software supply chain, according to Wikipedia, is a complex logistics system that consists of facilities that convert raw materials into finished products and distribute them to end consumers or customers. Now, it sounds kind of boring, but there are some important things there that I've highlighted. So the bolding and the highlighting is mine. The important thing is that there's a set of facilities that convert things, right, into finished products that then get distributed to customers. That's what a supply chain, not just a software supply chain, that's just what any supply chain does if it's successful. That's what a supply chain does for automobiles. If the cars roll off the assembly line and they don't work, well, guess what? You can't sell it to the customer. That was not a functioning supply chain. Same thing with typewriters, hard drives, or in this case, software. We have to provide the customers with a working product that they can use to fulfill our supply chain. So one of the things that I've worked on is helping people understand how to visualize what's in the software supply chain. Now, if you ask 10 different people what's in the software supply chain, you'll probably get 10 different answers. And most commonly, you'll probably get something along the lines of, well, it's, like open source libraries and stuff, right? And that's true. That is absolutely part of the software supply chain. But I think there's a lot more to it than just that. So what I've done here is I've created a 10-stage software supply chain visualization. And that starts all the way to the far left with the people that write and build the applications, the developer tools and local requirements that those people use, the source code that they write, how all this source code gets merged together and becomes one common code base. That's the integration phase. Then the deployment phase. When you take that unified code base and you do something with it, right? You build something that you can deploy somewhere. And that depends on whether or not you're building a compiled language or minifying it and whatnot with JavaScript. But there's always a set of deployment mechanisms. Next would be the runtime, how this thing actually runs and how it serves its purpose to customers. Then if there's any hardware that is required. Now you think, oh, hardware is part of the software supply chain? Well, sure, yeah. I mean, if the software supply chain requires a GPU, right? That's a really common one nowadays for AI. Or maybe a special custom PCB for some sort of OT, piece of equipment, or a USB dongle. Anyhow, some software supply chains are actually going to have a hardware component. Next is the DNS. So this is actually how we talk and how our customers interact with our web applications, typically APIs or web apps. Not all software supply chains are going to have a DNS entry. Next is services. These are the third-party payment gateways and identity providers and all that kind of stuff that an application needs that's not necessarily in those other stages, certainly not in the source code. And finally, if the application is deployed to the cloud or consumes or uses cloud services, that should be one of the supply chain stages as well. Now that's 10 stages. That's the number of stages that are totally possible, excuse me, for any software supply chain. What we're talking about today is actually open source software supply chain. And that's a little bit smaller, right? Because we don't have those later stages to the right of the kind of life cycle. Instead, we've got the people that write and develop these applications. We've got, their developer tools they use, their IDEs and so on and so forth, the source code, the integration, and sometimes, but not always, the deployment stage. So it's smaller. It's got less stuff in it. And why is it important for us to care about the software supply chain, whether it's the open source software supply chain or more complex ones? Well, the problem is that attacks are increasing dramatically. There's been a rise, a 700+% rise every year since 2019, as you can see on this graph. And I don't need this graph to tell me this. I'm seeing this myself, both, in my past life and now at GitLab where I am. The attacks in the software supply chain are increasing, and we need to be aware of it. Now, this was most recently kind of underscored to us with the xz-utils software supply chain attack. And I'm not going to go into a lot of detail about that, but that was very timely. That happened last weekend when I'm recording this. And the whole world, LinkedIn and Twitter, is abuzz about this issue. And I think the reason I put it in this presentation is that this is, I think, the first time where enterprise and large organizations realize that nation-state actors, these sophisticated, nuanced nation-state actors, have the time and the inclination to build multi-year attacks on the open source software supply chain. XZ has been around for many years. It's got a known set of collaborators, and the attackers, the malicious attackers, crafted a very, very complicated and sophisticated multi-stage attack on that software supply chain. So how do I know what's in my software supply chain and what are the risks? Well, historically, this has been really, really difficult, right? Again, you ask, 10 different people about what's in the software supply chain, you're probably going to get 10 different answers. It's hard to know what the risks are if you don't know what the ingredients are, right? And we're all really worried about what our risks are for our individual software supply chains. Now, here's the thing. If I'm a large organization, I don't just have one software supply chain, I have many. And the open source tools that I use, and there's many, many open source tools, they have their own software supply chain ecosystems. And that's why I created the Visualizing Software Supply Chain project. It's an open source project because the best way to help secure open source is by using open source. That's what I believe. The first step to that is understanding what's in your software supply chains. And the easiest way to do that, in my experience, is to use my project and my process. I kind of lay out those 10 stages, and then at each one of those stages, I help the user kind of walk through how to identify components at each one of those stages, and how to identify, what are some of the risks there, and also how to protect each one of those stages. I think this is probably the first place that every organization should start, and that's why I have this labeled first step. Understand what's in an open source software supply chain, whether you're the project maintainer of that open source project, like ProjectDiscovery, or if you're a consumer of open source, as most of us are. Now, one of the tools that I've used is the OpenSSF, which is the Open Source Security Foundation's scorecard tool. Now, scorecard is a great application that basically will help you understand the security exposure or profile, the security profile of a specific open source repository. And most projects are encapsulated in a repository. So OpenSSF scorecard, which has been around for a few years, you can just point it at an open source Git repository, and it will run a number of tests, and it will come back with a score, right? And this is what this looks like. In this case, I ran this against an open source project, and it came back, it gave me a score of 5.5 out of 10, which is meh. And you can see at the top there, just some of the many tests that it runs. Now, this is great because I actually myself, for my open source projects and for the projects that I work on, I like to run this in the CI/CD pipelines myself. I typically run this at the end of my pipelines when I'm building my projects. I run it after I create an SBOM, which I think is another very, very important step. I'm a big fan of SBOMs. But I run the OpenSSF scorecard at the end of that, right before it finishes. And that way I can go back at the end and say, hey, listen, I scanned, my own project in this case, after I'd done a new build, a new release of that, and here's a score. And I can see if it got better or if I got worse. This is a great project. Again, you can use this yourself on your own if you're a maintainer of an open source project yourself, or you can point this at your dependencies, your open source dependencies, right? Or at least the most important ones. And this is another thing that I do is I actually use this tool and I go through my package manifest or my SBOM and I identify some of those important components and I run this tool against them and I learn a lot. However, this tool, it's got several dozen different checks. There are a few gaps there, which I've identified over the years, and I've got my own kind of process about how to identify these risks in the software supply chains. And so I wrote something called TVPO. Now, originally this was called VBP, Value, Behaviors, and Patterns, but it's evolved over the years, and now I call it the Target, Value, Patterns, and Objectives framework. And basically what this is, it's a super, super flexible threat modeling and assessment methodology for software supply chains and for open source software supply chains. So the TVPO project allows you to identify risks and gaps in the security profile of open source projects or software supply chain, more complex ones for say cloud-enabled web applications. But regardless of what your target is, the whole point of this is to help me in my offensive security work as a red teamer to identify, what are the priorities that I want to focus on. But you can also use this as a defender. If you are a producer or a consumer of software and you want to understand, what are the threats inherent in a particular software supply chain, feel free to use the framework. In the context of red teaming, it helps me prioritize my targets. So it helps me identify those targets based on the attacker's motives and their objectives, right? What are the bad guys thinking? Why would they target my project or my application? What is there to be gained there? Who or what are the attackers focused on? Next, TVPO helps you identify gaps in your software supply chain security that attackers can leverage. These anti-patterns and behaviors and kind of tells and signals inside of your process. And because software supply chains are so broad, as you saw earlier with those 10 stages, there's a lot of moving parts there, right? TVPO helps you kind of step through each one of those stages and identify these patterns or anti-patterns. Next, it helps you prioritize what parts of a software supply chain you should work on first, what you should prioritize, and specifically on the risk to your organization for that particular software supply chain. Finally, it provides actionable playbooks. And this is my favorite part, right? Because I like to do stuff. I like to knock down doors and get the bad guys, right? So the playbooks inside of the TVPO project are specific, actionable, step-by-step guides to walk you through how to use TVPO to threat model or to assess a particular software supply chain, step-by-step, walking you through each one of those kind of serial steps. And I want to encourage the ecosystem to continue to build more of these playbooks for people to be able to use. So thank you so much today for having me. Thanks, Project Discovery. I really appreciate being part of this. I hope that you guys have enjoyed today's quick chat about open source security and the software supply chains behind those things. Again, my name is Paul McCarty. You can find me at pmccarty@gitlab.com. I look forward to talking to you. Thanks so much. Cheers.